Let's talk about equivalence relations. Equivalence relation is a relation which is reflexive, symmetric and transitive. Okay, go through the definition. Whenever a relation satisfies these three conditions, automatically that will become equivalence. Otherwise it is not. In the exam they give you a relation and they ask whether it is equivalence or not. How to check it? Simply check these three properties. Already I taught you how to check whether a relation is reflexive, symmetric and transitive. Use it. We'll take one example and see it. Let me take relation congruent modulo 5. A is congruent to B modulo 5 if and only if A is related to B. Let me use this relation. Is it equivalence is a question. So we know that A is congruent to modulo 5 if and only if A minus B equal to 5 into integer. We know that, right? Let's use it. Start with reflexive property. How to check reflexive property? Take a random element A. For that here domain is important. Let me take domain as integers. Okay. For integer domain, let me take one integer A, maybe positive or negative, doesn't matter. Then A is related to A or not is the open question. Ask yourself. If this is true, it is reflexive. Otherwise, no. I am taking only one element, but it is not, a particular element. It is a general element. So that's why if I prove for this element that A is related to A, then automatically it is true for every A. Let's do it. So A is related to A if and only if A is congruent to A modulo 5. But A is congruent to A modulo 5 if and only if A minus A equal to 5 into K. So A minus A is 0 equal to 5 into 0, isn't it? So K here is 0. Yes, 0 is an integer. That means A is congruent to A modulo 5 is true, A is related to A is true. So for every A, it is true that A is related to A for this definition. Now such relation is reflexive. Let's mark it. Second, symmetric property. So how to check symmetric property? Whenever A is related to B, we have to ensure that B is related to A. Let's take A is related to B as true. Then what happens is indirectly, so A related to B, then A is congruent to B modulo 5, then automatically you will get A minus B equal to 5 into K. We know that, right? So let me take A minus B equal to 5 into K as true, and can we prove that B related to A? B related to A means B minus A should be 5 into some K. Can we do it? Let's try to get B minus A equal to 5 into K from A minus B equal to 5 into K. If you can do it, then you are proving that this statement is true. Let's do it. B minus A equal to very simply 5 into minus K, isn't it? Then B minus A equal to 5 into minus K is an integer whenever K is integer. Then I got 5 into integer form for B minus A, correct? That means B is related to A. I took A related to B and I have ensured that B is related to A automatically. That means it is symmetric. Let's see the transitive property. What is transitive rule? If A is related to B and B is related to C, we have to prove that A is related to C. Let's quickly do that. A related to B. Then I can write A minus B equal to 5 into integer 1. Now B is related to C. Then B minus C equal to 5 into integer 2. So given these two as true, can we conclude about A and C? That means can we get anything like A minus C equal to 5 into K3? If you get it always, then it is transitive. So we have A's, B's, C's. What if I do? B can be eliminated? Addition. No other option, right? Let's do addition. If I do addition, you get A minus C equal to 5 into K1 plus K2. Since K1 plus K2 is integer, that would become 5 into integer. So A minus C is 5 into integer, which is nothing but let's say K3. So we prove